So we're on the final section of problem 2.4 in investigation 2, and we're looking at tessellation designs. Tessellations are designs where you move the image and there's no gaps or overlaps, and it's just the same image over and over again. But with a tessellation, we can either translate, rotate, or reflect the image that we want to begin with. So we usually start with the basic design element, and in this problem they've given us the basic design element. This was the design element that Rosalind and Tevin used to make their designs, but it looks like they used them in slightly different ways to create the tessellation pattern. And so what we want to do is try to determine if the basic design element itself has any symmetries. So if we look at this, does it have any types of symmetries like reflection or rotation of itself? We can always translate things. Translation is just sliding them around, and it looks like these easily slide around the page. But are there other symmetries to it? Could we rotate it? Could we spin this less than 360 degrees and have it look like it does? And it doesn't look like we can do that. Because of the shading, this side's darker than the other side. If I spin it, the dark side's going to be over here and the light side's going to be over there, and so I have to go all the way back around 360 degrees before I get this back there. So rotation symmetry doesn't work with this because I would want to have it look different than it does from this point. I want it to come back around something less than 360 degrees and then get the image back. Reflection symmetry also is a bit of a problem because of the shading. You can see that the shading disappears when I put that there, and the shape actually changes slightly. It's not quite the same shape as it was. Parallelogram shape goes away. And so that direction doesn't work, and this direction doesn't give me, now it's just all dark. So if I go down the middle, maybe that would work. Okay, does it have reflection symmetry? And you might notice it's hard to see, but the shape changes just a little bit, and you can tell by the line down the center. The line down the center is straight. If I put this in here, you notice that just very slightly that line down the center has a little bit of a bend to it. So it's not straight anymore. So it doesn't even have reflection symmetry. You can't take this image and reflect it on itself and get the original image back. So it has no reflection symmetry, it has no rotation symmetry, so the only thing that we can really see in the image itself is translation symmetry. Now that doesn't mean that we can't then reflect it and rotate it to make a tessellation, but at least within itself it does not have those types of symmetries. And oftentimes that's true of tessellations. They don't within themselves have those types of symmetries. But then when we take them, like in the case of Rosalind's design, and ask, how was this design repeated? What did Rosalind do? And it looks like for Rosalind's design, she just translated it from point to point. So really literally took this image and translated it right down the page like this, and right down the page here, and then right down. So each time she took the original image and really simply moved it along this line. So we could say that her direction was 1, looks like a little bit, maybe less than 1, more than 1, my line on the right place, more than 1. Looks like about a little more than 1 centimeter in that direction. So her movement, think of it as in that direction, whatever that distance is, I'll just call it 1.1 centimeters in that direction. So we take that image and slide it there. Now to get it from here to the next point over, or to the next set here, to get it from here to here, we can think of it that way too, like we just slid it from here to here. See the gray space there to the gray space there, the dark gray space to the dark gray space. So the other way to think about it is we could have just slid it to the right, looks like 2 centimeters. So in this direction, this distance, 2 centimeters. So we could go that way 2 centimeters and move the basic design element, which is, again, this is our basic design element. And if we move it 2 centimeters this direction, then it fits right in to this spot here. So we're just taking it and either sliding it down to the right or sliding it over to the right, down to the right 1.1 centimeters at that angle, or over to the right 2 centimeters. So that's our directions. If you want to move this, the length of the base basically to the right, or the length of the diagonal, either down or up, depending upon where you start. And so that's Rosalind's design. It's basically a translation. Tessellation. So we're just translating that image around the page. Now Tevin's design is slightly different. It's not just a straightforward translation, because you can see that to get this gray spot on this side means that somehow you have to rotate this image. Now we do have translation this direction, so the original image here is moved down that 1.1 centimeters this way, so we think of this part as a translation. So I have at least one part of it. Here's where we can combine different types of motions or movements. So we're really moving in that direction, the 1.1 centimeters. But to get this one into this position here, so we have this one. So if we translate this one down into this position, then to get it into this position, it looks like we have to rotate it 180 degrees. And the question is, where's the point of rotation? Where would I rotate it around to get it from that spot into this spot? And the point that you're looking for is halfway, if that's 2 centimeters, halfway, the midpoint, at 1 centimeter, right there, at that point. If I took and pivoted this, like there was a post right down the page, right through that spot, and I pick this up and spin it around that point, then this tip is going to go right to there, and this point is going to go out to there. Really literally like taking, I go from the long point here with my, because rotations always are circular in their motion. So if I take this point, see my point there, and circle, so I'm going to make a circle out around, see if this will hold up here. See that it rotates right back around into that spot right there. So that point, this point here, rotates along that arc into that point, which is exactly what I wanted it to do. If I rotated 180 degrees around that point, that's my center of rotation. And that's my arc, that's the rotation. And you can see it's basically half a circle, so it's a 180 degree rotation. But we also have a translation in this part. So we have a translation, 1.1 centimeters in this direction, down to the right, and then a 180 degree, you can think of it as counterclockwise rotation, or clockwise, either way. With 180 degrees you can go either direction. So 180 degrees one way or 180 degrees the other way. We'll put this into this position. And then once again we could just slide it down 1.1 centimeters from here to here to get it into this position. So you're doing two things in this one. You're translating down, you're rotating to flip it around into this position, translating, rotating. So you're going to do a translation and a rotation in order to create Tevin's design. Center of rotation is at the midpoint of one of these pieces, and that's the spot that you rotate the image around to get it to the next point. So we have two basic designs, two designs that are from the same basic design element, but by doing different things to them, either just translating or translating and rotating, then you can create actually different looking designs, and the shading creates that. And then if you think about the entire tessellation, does this entire tessellation, do they have any reflection symmetry? Do they have any rotation symmetry? Can I take this whole design and find a point of reflection in it where I can take the original image and reflect it on itself? And it doesn't look like it does. So, and part of that is the original design element does not have any reflection symmetry. The way that design was created did not use reflection. And so the element, or the whole translation, this whole design does not have either rotation or translation symmetry. So let's look at this one and see if we can find any, in Tevin's design, any points of reflection. That doesn't work, doesn't help us. Maybe this way. No, again, so because we didn't have any reflection symmetry in the design or in the tessellation, we didn't use reflection to tessellate it, then the overall design doesn't have any of that. Now the other question is, what if I rotate it? What if I take the whole design and rotate it? Is that 180 degrees? Does that look like, or would that look like the original design? Do I still have what I started with? So let me flip it around again and see. Maybe it would be easier if I took another one just like it. We'll put them side by side. So are these two? Here's the original, and here it is flipped over upside down. So let me zoom out just a little bit so we can see both of them at the same time a little bit better. And this will answer the last question for us. So let's try to go in the other direction. We'll be able to see more. So we get out to, go. So there's the original, and here it is flipped over. So do we get the same image? It's a 180 degree flip. So part of it is, if you look at these pieces, are they in the same line? So I'll let you decide if you think that we have 180 degree rotation symmetry. And really the clue is, what did we do to this design to tessellate it? Did we translate and rotate? If we translated and rotated the image, then the image itself, the overall image, should have both translation symmetry and rotation symmetry. If it doesn't, if it only has translation symmetry, then it won't have reflection or rotation symmetry in the overall object. And so that's tessellations. Tessellations, there's lots of kind of interesting designs. If you look up tessellations on the internet, you'll see a whole bunch of amazing sort of artwork that's centered around tessellations and taking designs and repeating them over and over again and using them to create patterns. And so that finishes up investigation 2 from kaleidoscopes, hubcaps, and mirrors.